Hello class. In this lesson we're going to learn how to calculate perimeter and area in the plane. As a warm-up, I'd like you to calculate the area of each shaded region here, and if you have to round to the nearest hundredth. So try these on your own and I'll show you my solutions. So in A, we have a square with a triangle that's been taken out of it. Area of the square is 16, the area of the triangle is 2, and so the shaded region is 14 square units. In letter B, we have a circle. Its area is 9 pi. And we've taken a rectangle out of it, so we subtract 8, and we get about 20.27 square units. Now, we're not always going to have figures on the plane that have sides that are vertical and horizontal. For example, this triangle. So first thing we want to do here is figure out what's the perimeter of the triangular region. Well, we can figure out each side length here by either using the Pythagorean theorem or the distance formula. They're really the same thing. So if we do that for all three sides, we end up with 5. Square root of 8, and square root of 29. Don't worry about simplifying any radicals. We're just going to estimate these distances on the calculator. So to calculate the perimeter, we add all three of these together. Let's round to the nearest hundredth again. We get 13.21 units. Okay, is our triangle a right triangle? Well, we know multiple ways to check this. We already have side length, so let's check using the converse of Pythagorean theorem. Right? If it satisfies the Pythagorean theorem, then it's a right triangle. If it doesn't, then it's not. Now, unfortunately, when we substitute, it does not check out. So it is not a right triangle. How can we figure out the area of this triangle? Well, we know the formula for the area of a triangle is 1/2 the base times the height. So if we knew a base and a height, we could calculate its area. But unfortunately, we don't have a height here. This isn't a right triangle, so we can't just multiply the legs for a base and a height. So we'd have to use some trigonometry to figure out what a height was here. Now, can you think of a way we could do this without trigonometry? Because that can get a little bit messy. So it's another way to calculate the area of this region. And as a hint, think back to the opening exercises. Well, we're going to draw a rectangle around this triangle and use subtraction to figure out what the area of the triangle is going to be. So what do I mean by that? We're going to draw a rectangle so that each vertex of the triangle lies on the rectangle. And what is the area of this rectangle? Well, that'd be 4 times 5. That's 20 square units. And so how can we figure out what the area of the triangle is in the middle? Well, we know the area of the rectangle. We just have to subtract the area of the 3 triangles. So go ahead and find the areas of each of the triangles. Try that and I'll show you my solutions. So for the triangle on the left, you should get 6 square units. For the one on the right, 2 square units. And the one on the bottom, 5 square units. So now we take 20 and we subtract these 3 numbers from it, and we get 7 square units. Now we're not always going to have a triangle. We could have other figures. So here we have a pentagon. We'll zoom out for us. And first we want to figure out its perimeter to the nearest 10th. So try that on your own, and I'll show you my solution. So we figure out the length of each segment here. We end up with these numbers. And we add them all together. To the nearest 10th, we get 30.3 units. Well, what if we want to find its area? What do we get? Well, in this case, if we just draw a big rectangle, we end up with a region that isn't a right triangle. This isn't a straight segment here. So how can we get around that? Well, the idea is you want to make each piece here, each side of the polygon, you want to make it a hypotenuse of a right triangle, just like we did when we were calculating the perimeter. And so if we make each of these a hypotenuse, so that the triangles lie outside of the region, we will end up with a rectangle that goes around the outside. And on the inside, we will have all either rectangles or right triangles. And we know how to calculate those areas very easily. So in this case, this is the region we end up with. Well, let me ramp to the front. There we go. So if you notice, each gray area is either a right triangle or a rectangle. So why don't you go ahead and see if you can finish the problem. See if you can figure out all of the areas here and use that information to figure out the area of our pentagon. So if we did this correctly, you should end up with these areas. I wrote them in blue here. And so the area is going to be the area of the rectangle, which is 77, minus each of these little areas, which gives us at the end exactly 50 square units. In this lesson, we learned how to calculate perimeter and area in the Cartesian plane. Thank you for watching this video.